Now let's talk about dead state. Now to understand this, let's pay attention to these two plots. The first one is a PV plot, okay, and the second one is a temperature entropy plot. Now in this we talk about a term called dead state, and in conjunction to it we will also introduce a new term, but we'll define that in another video, and that term is availability. Now availability is, or it is an indication of the amount of work that can be extracted from this or from any system, okay, or it is a measure of the available energy. Now if you talk about the dead state, let's first of all look at the diagram. So in the PV plot you have an isotherm which is at temperature T0, so this is the temperature of the surroundings, and an isobar which is at pressure P0, so this is the pressure of the surroundings, okay. In the TS plot you have an isobar at pressure P0, again the pressure of the surroundings, and an isotherm T0 representing the temperature of the surroundings. Now the thing is that if the state of a system departs from that of the surroundings, that is, let us say initially the state of the system and the state of the surroundings are same. So you have a surrounding at pressure P0 T0, okay, so P0 T0 for surroundings, this is equal to P0 T0 for system. So when this condition occurs, there is no available work that can be extracted from the system. But when you have a system which is going away from these states of the surrounding, that is, when you move from point O to point 1, the availability will increase. That is, an opportunity will start arising that can help you in producing work. But on the other hand, if the system changes its state towards that of the surrounding, so it is the case when, let us say, your system is at state 1 dash. So from 1 dash you start moving towards the state of the surroundings at point O. At this or during this duration, the availability will start decreasing, or it will start diminishing, and it will cease to exist when the two, that is the system and the surroundings, are in equilibrium with each other. So if you summarize this, okay, to summarize this, a system, okay, going away from P0 T0, okay, this means the availability will increase. That is, you have a chance of getting more work out of the system. And when the system comes toward the surroundings, that is P0 T0, this means the availability decreases, and the availability becomes 0 at this juncture, that is, when the surroundings and the systems are in equilibrium, that is, they have equal pressure and equal temperature, that is, they have pressure equilibrium and thermal equilibrium. It must also be, that is, the system and the surrounding must also be in chemical equilibrium, that is, there should be no chemical reaction or mass transfer between system and surroundings, okay. So there is one more thing. So you can say that when you have P0 T0 of surroundings equal to P0 T0 of system, then you can say that you would have a pressure equilibrium, okay, you can have a thermal equilibrium, and lastly you will have chemical equilibrium between system and surroundings, okay. Now the system must have zero velocity and minimum potential energy. So when this thing happens, the system will have zero velocity, so the velocity becomes zero, and the potential energy, it becomes minimum. Okay, so this state where the pressure equilibrium exists, where you have thermal equilibrium, where you have chemical equilibrium, where you have zero velocity and minimum potential energy, such a state of the system is known as the dead state. Or in simple terms, when the state of a system becomes equal to the state of the surroundings, then at that point the system is said to be under, or you can say at, dead state. Okay, and any deviation or any movement or any change in the state of a system from the dead state is a measure of the available work. Okay, so if you go back to the diagram again, so point O, this point, this is known as the dead state, because at this point the system and the surroundings are at same condition, and this point also on the TS plot is also known as the dead state. Okay, so this means the farther you go as a system from the dead state, higher will be the extent of the amount of the available work. Okay, now there is one more point that you should note that comes from this particular plot, that is the TS plot. So let us say you have any system at state 1. Okay, now state 1, from state 1 there is a spontaneous process that starts. So the spontaneous process then approaches the dead state. Similarly, if you have a state 1 on some other point in the TS plot, then from this point also you have a spontaneous process, and this spontaneous process also moves towards attaining dead state. So this means that all spontaneous processes, they terminate at the dead state. Okay, so this is another point you should note down, that is all spontaneous processes end at dead state. Okay, so this is a very, very important topic to understand, that is the definition and the understanding of what a dead state is. Okay, make sure you note down these conditions of existence of a dead state and what is the meaning of dead state. Okay, so now after dead state, let's talk about what is availability.